Welcome to Camtasia. This sample project will provide a quick tour and get you started. If you're looking for more in-depth tutorials that walk you through the entire process of recording, editing, and sharing your videos, check out the video tutorials on our website. And if you want to open a fresh copy of this sample project, you can find it in the Help menu. Right now, you're in the Camtasia editor. The editor is made up of the timeline, where you can arrange and edit your clips, the canvas, which is your video preview, and the tools panel, where your media is stored, along with shapes, animations, effects, and more. At the top of the tools panel, there's a button to launch the Camtasia Recorder, a tool that captures all of the action on your computer screen. When you're done recording, each clip will be placed in your media bin and on your timeline. If there are parts of your recording you don't need to show, you can trim them from the end or cut them from the middle. If you'd like to add other media, titles, or effects, drag them from the Tools panel to the timeline. If you choose an effect, such as an animation or transition, the clips on the timeline will highlight, showing you where it can be applied. While you're working on your project, use the canvas to position your media and preview any edits you make. You can use the Properties panel to fine-tune your media and effects, such as positioning an object to an exact location, rotating an object, or even changing its scale and opacity. When you're satisfied with your video, produce it, either as a file on your computer or share it directly to popular web destinations. Now it's time for you to try. To get started, experiment with this sample project. Try deleting or adding clips to the timeline, or maybe add a transition or effect to something that's already there. You can always open a fresh copy of this project from the Help menu. When you're comfortable, start a new project to create your very own video. If you're looking to do more with your project, like adding animations, quizzes, or even importing your own video, check out the tutorials on our webpage. Thanks for watching.
Hi guys. So what we're going to do now is a lesson in A-level physics with one of my students whose name is Hamza. He's been studying with me for a number of years. He's a great student and we're going to go over some A-level physics. Okay? So before we start today's lesson, I'd like to run you through the spec of what you need to be able to understand for the physics syllabus you're doing now. I'm going to share my screen with you.
Yeah.
This one right here. Okay, can you see that?
Yeah.
Okay, so let's just recap what we done last week. Last week we covered, if I go up, the topic of vectors, yeah? We'll start the lesson properly in a few minutes, but I just want to go over like this housekeeping.
Yeah.
All right, so we looked at what scalar and vector quantities were. Do you remember?
Yeah.
Can you tell me the difference between a scalar and a vector?
Scalar only has magnitude.
Yes.
And a vector has magnitude and direction.
Perfect. Can you give an example of a scalar and an example of
Oh,
a
like an example. Okay. A scalar could be speed.
Yes.
And a vector could be displacement.
Excellent. Why is displacement a vector and distance not a vector?
Because displacement, when it goes round, it has a direction as well as a magnitude. So it will when it goes from start to finish, it will either be minus or positive. Okay.
The difference between.
Yeah.
Can you read my handwriting?
Yeah.
Displacement, yep, and distance. I want you to explain that by writing it down as you would explain an exam question.
Okay, let me just write a question.
Yeah, of course. Let me just make it a bit neater. Also, I want you to use examples.
Okay.
In your explanation. Examples always help.
in our example, can I draw or do I have to write?
You have to write with an explanation. What we're trying to do here is get your English and your literacy at a level which will help you pass an exam, rather than an examiner looking at your answer and thinking, I don't understand what's going on here. So you need to have literacy. That's what we're practicing. Now, how is that different to distance?
Distance doesn't have distance doesn't have a direction.
Yes, distance doesn't have a direction. It only has a magnitude. Yeah. So distance is the magnitude of how far point A is from point B. But it doesn't tell you the direction from point A to point B. Yeah. Whereas displacement has two things. When you're going from point A to point B, you're looking at the distance between the two, and you're looking at the direction. So here, if I wanted to go from A to B, I'm going to travel some distance. Let's say it was 5 meters. 5 meters to the right.
Yeah.
So I've got 5 meters, which is part 1, which is your magnitude, and I've got to the right, which is part 2, which is your direction. So the vector includes two things in it. It always includes a magnitude and a direction, whereas a scalar only includes a value of magnitude. Make sense?
Yeah.
Now, I'm sure you wrote that last week in your notes. So one target for you, Hamza, is to really look over your notes in detail after you finish lessons, yeah? And you can go on Google Classroom, as you know, and you'll find all the notes on there. Is that okay?
Yeah.
Well done. You remembered some of it. It's just that there's a target for you to remember a bit more now, as we know.
Okay.
Okay. So what we're going to do...
What's the date today?
The date today is the 25th of March.
That's all right.
Have you not got a calendar over there?
No, I don't have any. I just have a clock.
At the bottom right-hand screen of your computer, you'll usually have...
but I can't see it. Wait. Okay, I can see it now. Yeah.
Okay, fine. That's fine. All right. So, ready for today's lesson?
Yeah.
We need to do one more thing before we start today's lesson, but we'll do it.
We finished off on the terminal velocity.
We did. And I've been looking at what we done last time, and we're going to add to that. Today's lesson is kinematics, as you can see over there. We're going to be looking at the Suvat equations. Okay.
So we're going to do Suvat. Yeah.
All right. Now, today's objectives are going to be the following. The following 4 things. The first thing, we're going to start recapping last week's lesson. Last week, we learned about how a vector quantity can have individual components to it. So our first objective is going to be that we're going to recall that a resultant vector quantity can be resolved into individual components. Objective number 2, we're going to understand and recap the equations of motion. Now, you've done the equations of motion at GCSE. You've done it briefly at A-level as well. So some of this topic should be a recap for you, and some of it should be a further understanding that we're going to learn. Okay?
Yeah.
We're going to explain, the third thing we're going to do is explain how to experimentally determine gravity. So if I want to find out the value of gravity on this Earth, the value of gravity is 9.81, as a number. If I want to find that value out, what experiments could I do to help me figure that value out? After we do those 3 objectives, we're going to apply our knowledge of all those 3 things that we've learned. And we're going to apply our knowledge in terms of doing exam-style questions. Clear?
Okay.
All right. So let's start recapping last week's lesson. I'm going to share my other screen with you because I want to ask you a question or two on last week's lesson. If I can find the thing, smooth draw. Okay, so we're going to make a new slide here. All right. I don't want to save the picture. Ready? Can you see my blank screen here?
Yeah, I can see.
So imagine I throw or I kick a ball. Let's say I've got a tennis ball or a football, to be honest, and I kick it upwards, and it goes up with a speed of 5 meters per second. Now this ball, I've kicked it upwards at an angle to the ground. This is my ground over here. Right ground. And here is an angle, theta. So the ground, let's say, goes this way, and we have an upwards component going that way. I want you to find the speed. So I'll write it down here in a different colored pen. Okay. Calculate A, which is going to be the speed of the ball vertically, which is the speed I kick it up at. Yeah? And B, speed, spelling's terrible there, what am I doing? Speed of ball horizontally. I'm going to give you a few seconds to do that, and then I want you to take me through the method you've used. Let me give you an angle. So let's call theta, this angle over here, theta, let's call it 30 degrees, yeah?
Okay.
Clear? So that angle there is going to be 30 degrees. I'm going to put some answers here. I want to see if you're getting the same thing.
I got 4.3 and 2.5. Yeah, I got that.
Excellent. You got the same answers as me, yeah?
Yeah.
Good. Well done. Now, the reason you got them is because you understood that 5 cos theta, 5 cos 30 is going to give you this component, and this 5 sine theta is going to give you this component, which the angle's not connected to. Make sense?
Yeah.
Okay, so that's very good. We've successfully recapped last week's learning, and I'm happy about that. Okay, so we've done objective number 1. So if I go back to your PowerPoint, you clearly understand how to calculate the individual components of a vector quantity.
Yeah.
Yeah. All right. So now we're going to recap the equations of motion. To do that, I want you to tell me what the equations of motion are. There's 4 equations of motion.
Yeah.
Tell me.
Okay.
Write them down on a piece of.
Yeah. Done.
Okay. What did you write? Show me your answers on the camera.
I don't know if you can see.
I can. Let me just make it a bit bigger. Okay. All right. Let's see. S equals ut. Just hold it in one place because it's like following a basketball. S equals ut plus half at squared. V equals u plus at. V2 equals u. Perfect. 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 Well done. Okay. So I've got all of your answers, and I can see that you've done it correctly. I'm going to start putting them up here as well. These are the equations of motions I've got. They're very similar to yours. Okay, now what I want you to do, because you've done this before, I want you to apply this to some questions now. Is that clear?
Wait 1 second. Equals.
Okay, you can add some answers on.
Done.
Done?
Yeah.
Okay. So I'm going to give you 6 questions on this topic now, as you can see on the board here. As soon as you do one, we're going to look through the answer together. Okay?
Yeah, I got an answer.
Okay, what did you get?
I got 3.
3. I'm going to see if the answer is correct. Correct. Well done. As you can see, it's the correct answer. The working out is here. So when you go on Google Classroom, if you want to look at the working out, you can see it all here when you press the equal.
Yeah, I did that.
Perfect. Let's go to the next one.
I got 5.1 meters.
5.1?
Yeah.
Okay, good. So that recap sorted. I think you've understood this topic. Okay. Therefore, so I think you've understood the equations of motion. We're going to look at the experiment, the required practical now to determine gravity. Is that okay?
Yeah.
Okay, let's do that. I'm going to give you an example of an experiment, yeah? Can you see what's on the board right now?
Yeah. Yeah.
Can you see that diagram?
Yeah, I can see it.
Let me put it up for you. Okay. I want you to use, this is your task, yeah?
Yeah.
I want you to use this diagram and write the steps of an experiment you could use to determine gravity.
Okay.
Yeah? You might need to put your camera back on because it's gone off.
No, I think it's enough. Okay, yeah.
Okay, go on.
So what do I need to do? I need to determine?
I want you to write down the method of an experiment based on this diagram that you could use to determine gravity.
Okay. I didn't do this one before, but
this is the type of question you might get, where you have a situation and you've got to use it to determine a value. So you wanted a challenge? Here's a challenge.
I wrote one thing now.
Tell me what you wrote.
I wrote that time how long it takes for the ball to hit the paper.
Okay, so let's stop there for a second. Can you see my new screen here? The whiteboard?
Which screen?
The whiteboard. I've just put whiteboard.
Oh yeah, I can see.
So let's look at this experiment. Yeah, I'm going to write down what you write as you write it. So we're going to look at determining G, okay? And what you've written so far is time, how long the ball takes to fall, right?
Yeah.
Okay. Now, you've got time from that.
Yeah.
How are we going to use this to determine the value of gravity? Could you say anything else? I need a full method of how you could use.
Maybe, I'm not sure, but maybe you could, let me think.
Tell me.
First, get the distance
Yeah.
of the string, the ball, and to the ground.
So the distance between what? The table and the ground?
Yeah.
Okay. The vertical distance?
Yeah, the vertical distance.
Okay. Vertical distance.
Okay.
Between.
Is G?
Yeah.
Is that the same as A?
Yes, it is. Because gravity is the acceleration towards the Earth.
Yeah. So then you do. So you get the time.
Okay, so we've got two things now. We've got time.
Yeah.
We've got S, which is your distance. Yeah.
Yeah.
Okay, good.
And but initial velocity, because you're about to start the experiment, initial velocity is 0.
Initial velocity in which direction is 0?
In the vertical direction. No, in the horizontal direction.
Initial velocity. Are you sure? If you throw a ball
No, in the vertical direction. The vertical direction.
in vertical direction equals 0. Good.
I think then you do SUVAT.
You can do SUVAT, yeah? Tell me which equation you could use.
S equals UT plus half AT squared.
So U is 0, yeah? So we're going to use S equals UT plus half AT squared. Now, tell me what you could do with that equation.
U equals 0.
So because U equals 0, because this thing here equals 0, we can cross this whole thing out. Agreed.
Okay, and then you have S already, so you just rearrange it to get A.
Tell me how you rearrange it.
So it will be 2S over T squared.
So let's check that. So let's see. 2S over T squared
equals A.
Well done. Good. You've got the right method here. Now, in an experiment, you want to have accuracy. How could we improve the accuracy of this experiment or this investigation? What can we do?
Take more readings.
Okay, so you take more readings of what?
The ball going on the ramp.
So which value are you going to get in more readings?
You're going to get more time.
Yes, so take more readings of time. Okay, take more readings. When you take those readings, what do you do with those readings of time? Let's say I take 10 readings of time to drop that ball the same height. What do I want to do to those readings?
You get like an average value.
Yes, you average those because the average gets rid of your inaccuracies. If I do the average, what do I reject? I want to reject something when I get. If I have 10 readings, there might be some readings that are what?
Anomalies.
Anomalies or outliers. So reject the outliers. When you get an average, you never use your outliers. Yeah, does that make sense?
Yeah.
Okay, good. You got a good idea of it. But what I'm going to show you now is a different way to approach it. The way that they want you to approach it. You've got the right idea, so I have no problems with that. However, when you do an experiment like this, can you see the drawing again?
Yeah, I can see.
Yes, no?
Yeah, I can see the.
Yeah? Okay, can you see me? I'm scrolling through the pages.
Yeah, I can see.
Okay, so look at this. Finding the horizontal velocity of a marble and finding G. Look at this. It's got S equals UT plus half AT squared. You've identified the correct equation, so well done for that. It's got V equals U plus AT and speed equals distance over time. You don't even need these, to be honest, but they're going to be useful to work out other things. Now let's have a look at what's going on. So you first measure the vertical height of the drop, how far you are off the ground. Yeah, which you done, correct. So I'm going to tick that and say you got that point. Measure the time of flight, correct. You said measure the time. Measure the horizontal range. Now this is not going to be so important for gravity, so we're going to skip that for a second, yeah? But this next point here, or point number 5, we're going to skip point number 3 and 4 because they're not concerning what we want to work out. We just want to work out gravity. Point number 5 is interesting. Draw a graph of height against time squared. Use this graph to find G. Do you see what they're doing here?
Using the gradient
of the graph.
Yeah.
So you're basically having a graph whose gradient you're going to use to find gravity. And I'm going to show you why that works.
Do you have like a what's the word? Like an apparatus like picture.
Like what, sorry?
How the apparatus would look.
How the apparatus would look.
How it's set up.
1 second, let me show you, because there is something you're missing. So how that, we're going to draw it out, okay? Okay, don't worry, I'm going to give you extra time, so you're not wasting time here. No. Basically, you want to draw a graph, right?
Yeah.
What are you going to have on your X and Y axis? That's what I want to ask you.
Height against time squared.
So where's your height and where's your time going to be?
Height is going to be, its height is going to be the X axis.
Yes, so because height's an independent variable, yeah?
Yeah, independent, yeah.
Height's going to be in meters, and time squared is going to be here, yeah? That's going to be in seconds. So if height's an independent variable, what am I going to be changing all the time when I drop the ball?
The time's going to change.
The time's going to change, but based on what? Based on the
height.
So because height's my independent variable, I can drop that ball from different heights. I can drop it from one height, and then I can drop it from a higher height, and then a higher height, and then a higher height, you see? So I'm dropping it from one height, I want to get the value of time for that height squared. I drop it from another height, I get the value of time squared for that. Do you see what's going on?
Yeah.
I can plot a graph, you see? And when I have that graph, there's going to be a gradient, a change in y over a change in x. And that gradient is simply going to be time squared over height. Do you see what's going on here?
Yeah, I understand.
If I reverse it, it's going to be height over time squared.
That's right, yeah.
Yeah. Now, if we go back to our PowerPoint, we're going to see something. Because if you do height and you divide it by time squared, what does that leave you?
Height over time squared. That's 2s over t squared.
Let's do it. Let's do it. Let me,
which equals to 8.
Give me 1 second. Yes, so you get acceleration from there. Do you see how that works?
Yeah.
So do you see how that's different to what you said to me?
Yeah.
What you said was you're going to carry on dropping the ball from the same height and, you know, measure the time for that, which can be done. But the other approach is to change the height, make your height your independent variable, create a graph, and use the gradient of that graph to calculate what your acceleration is.
So can I write this down on the PowerPoint?
Yes, so what I'm going to do, I'm going to put this PowerPoint up again. Can you see it?
No.
Okay, so I'm going to just share it with you because sometimes it's a bit weird. Can you see it now?
Yeah.
Okay, so there you go. I want you to write that down. I want you to draw a diagram of a graph and then explain next to it what equation you're using.
Yeah, done.
Okay, does it make sense to you?
Yeah.
Okay, it's a very important experiment to keep to be wary of, okay?
Yeah.
Now, I think you've got your gradient and everything right. You've understood how to do it. You've understood the method. Any problems there? Any questions?
No.
Okay, let's move on. So let's have a look. Now, on your syllabus, we have, let's just go through what we've done so far, yeah? Scalar and vector, can you see it?
Yeah, I can see it.
Scalar and vector quantities, right? We've done that. Agree?
Yeah.
Under focus. Vector addition and subtraction.
Yeah, and we've done that as well.
We've done that, right? Vector triangle to determine the result of any two coplanar vectors.
Yeah, we've done that as well.
We've done that, and you're okay with that?
Yeah.
Resolving a vector into two perpendicular components. We done that?
Yeah.
We did it
Yeah, I
today.
understand.
Okay, so you're okay with that. Now, forces and motion. We looked at, I'm going to come back to this in a second, but I'm going to show you what we done today. We looked at all of this.
Yeah, I understand that.
You understand that? And I think you're quite good at it, to be honest.
Yeah.
We also looked at this.
Yeah.
Yeah?
Yeah.
Investigating motion, your techniques. We're going to return to these 3 exam questions, so don't worry if you feel you've forgotten anything. We're going to do exam questions anyway.
Yeah.
Does that make sense?
Yeah.
Yeah. Acceleration of free fall gravity. We just done an experiment on that.
Okay.
Hamza,
Yeah,
you
we just did that. Yeah.
okay. So next one. Oopsie daisy. I'm going a bit fast. Let me go back up. Techniques and procedures used to determine the acceleration of free fall or gravity using a trapdoor and electromagnet arrangement, which we've done.
We done that in the previous tuition center.
Yes, and you've got the notes on that, right?
Yeah, I got the notes on that.
But we don't need to repeat it, do we?
No.
No. Now, I'm going to go back up for a second and look at some of the other things we've done in the previous tuition center, which is graphs, displacement, speed, velocity, and acceleration graphs.
Yeah.
Remember that?
Yeah, I remember that.
Your homework this week is to go over this stuff and make sure that you have nothing that you don't understand in it.
Okay, yeah.
Because if I went through it again in lesson right now, we'd be spending time on something you've already done.
Yeah.
So I'd rather you go home and look at it and then tell me if there's something you don't understand. Clear?
Yeah. Yeah.
Okay, what about this? Displacement, time graphs, velocities.
Yeah.
Yeah, all of that okay?
Yeah.
Okay. So I think we finished the first, oopsie daisy, sorry. I think we finished the first section. We don't need to do any more on there. Okay. We've also finished the second section here. Projectile motion.
You done that as well?
You did do that.
Yeah.
Tell me if you want to go over something again over here.
Let me look through the other stuff.
Yeah.
I think projectile motion's okay.
Hmm?
Projectile motion, I think I'm okay with that.
You okay with it, yeah? Do you
Yeah.
understand how horizontal and vertical motion are independent of each other?
Yeah.
Do you want to, we can maybe do one question on it later if you want to make sure, yeah? But before we
And
get huh?
I think we start from
Let's read through this 1 second, yeah, Hamza? Let's
Okay.
let's go for it to make sure. So mass times acceleration.
yeah, know that.
All of that's okay, yeah?
Yeah.
Free body diagrams.
Yeah.
So everything I've highlighted in blue you're okay with?
Yeah.
Okay. We looked at drag. We looked at when you drop an object in a viscous fluid, how to determine
Yeah.
terminal velocity.
Yeah.
Okay, so drag. Can you see my board?
Yeah.
Okay, drag. A block of butter, for example. I've got another butter here, yeah? Anchor butter, for example. And I want to cut through that butter, and I use my knife. My knife's over here. And I'm trying to cut through that butter. Which way do I aim my knife? Do I do the sharp bit? Because now this sharp bit has less drag from the butter. Less butter molecules will hit the sharp bit and slow it down than they will hit the flat bit. If I put the flat bit of the knife on the butter, more molecules of the butter will exert resistive force on the knife. Does that make sense?
Yeah.
So the shape of an object affects the drag acting on it. Clear?
Yeah.
Now the second thing, this bowling ball and this feather, if I were to put them through honey, what's going to happen to them?
Will
they go faster or slower?
slower because
No.
the density of the honey.
No, not the density.
Not the density. The I don't know what the word is.
It's called viscosity.
Viscosity. That's it.
Yeah, so viscosity of fluid. That's the second thing that affects drag. Okay. Does that make sense, Hamza?
Yeah. So.
Okay, good. So now, when we're going to go back, and look at your OCR. What do you call it? The OCR specification. Can you see it?
Yeah.
Look at the first point it makes. Drag is a frictional force experienced by an object falling through a fluid. I want you to write this down as a note. Drag is the frictional force experienced by an object falling through a fluid. That's what drag is.
So drag is the frictional force.
Yes. experienced by an object falling through a fluid. Can you see it?
Yeah.
Good. Shall I make it bigger or can you see it okay?
No, I can see it.
Okay. So while you write that down, can we consider air as a fluid?
Yeah.
Yeah, why?
Because the object experiences drag in the air.
Air is a fluid because the molecules of air pass over each other. You know, when molecules can pass over each other, you have a fluid. When molecules or atoms can't pass over each other, you have a solid when they're in one place.
Okay.
Okay. Honey is a more viscous fluid in air than air because the molecules of honey have more resistance to passing over each other. Does that make sense?
Yeah.
Okay. Now this is all recorded, Hamza. So whatever we say in this lesson, you can look at it later in case you missed something. Does that make sense?
Okay. Yeah.
Okay. Right. So the factors affecting drag for an object traveling through the air. If an object is traveling through the air, what's going to affect its drag?
The shape.
Of what?
The shape of the object.
Yes.
And the how aerodynamic. No, the same thing.
The aerodynamics of the shape are related to each other.
Yeah.
The more sharper an object is, or the more streamlined an object is, the faster it will cut through air molecules. It'll be more aerodynamic. That's one factor. What's the second factor affecting the drag? We just said it.
The viscosity.
Of air, right? Or the fluid.
Yeah.
What's the third factor that affects drag on Earth in a sense? You mentioned it.
The weight.
Okay, good. So you've got three things now, which we've discussed. We're going to talk a little bit more about weight and why sometimes it's not considered as a factor, but that's going to come later. Okay. Now, the motion of objects falling in a uniform gravitational field in the presence of drag. What that means is if the gravity is the same, like on the Earth, the gravity is similar everywhere you look, right?
Yeah.
Okay. How does that affect the motion of an object? We're looking at something called terminal velocity. Last week, you filled in you done an exercise with me where we analyzed the movement of a parachutist. Do you remember that?
Yeah.
Okay. So that is what this is talking about. Okay. You have to be able to draw the graph of how a parachutist moves through the air, and you have to be able to explain the different aspects in the journey of the parachutist. Remember how we wrote down the fill in the blanks task last week?
Yeah.
So basically, it's just talking about that.
Okay.
That makes sense?
Yeah.
Now, the next bit, techniques and procedures used to determine terminal velocity in fluids. What you told me earlier, the experiment where you're dropping a marble through a thick fluid. Do you remember that experiment?
Yeah.
Okay. Do I need to go over it?
Not really.
You sure?
Which one? The ball bearing one?
Yes. I want you to have a look at your notes and see if you understand it. Okay?
No, I didn't write that down.
We didn't do it together. It's from your notes in school.
Yeah, in school. No, yeah, I have it in school. No.
Do you understand how to do that experiment, or do you want me to explain it?
Can we just go over it? Like, do you have like a PowerPoint that shows how to do it? Yeah.
I'll go over it with you, no problem. Yeah. So again, don't worry. I'm going to give you some extra time, so don't worry about it. So I want to make sure you benefit in this lesson, learn something. Let's look at terminal velocity. How's it done, Hamza?
It's okay.
Is it okay? Is he in a good mood?
Yeah.
Good to hear. Oh, yeah, by the way, before we look at terminal velocity, I want you to add something to your previous experiment here. Remember when we took notes on measuring G?
Yeah.
Here's a bit more on it, just to make sure you've got the right information, yeah? Do you see that? Use that. So here is the comprehensive explanation of how that graph works. Notice what they've done. They've put the displacement on the y-axis, just so that they can get the gradient easily. Technically, we should put it on the x-axis because it's independent. Does that make sense?
Yeah.
Good.
Done.
Okay. Are you sure you get everything over there?
Yeah.
Okay, good. Let's move on. You done it?
Yeah. And yeah, I haven't done that one.
Let's do this one.
Yeah.
Yeah, start to finish. You can see which question number it is as well. I want you to look at your syllabus, yeah? I want you to think about what you want me to teach you. Now, the thing is this, there's all of this stuff that we've done. What I want you to do with the stuff that we've done already is do exam questions on it. And when you do exam questions on it, you'll find out what you're weak on. And then you'll know what you need to learn. Is that clear?
Yeah, I've got, basically, this like 3.13, 3.12. My teacher's printed out, my dad prints out, my teacher put some stuff on to show my homework.
Yeah.
So, you know how last week I showed you those questions?
Yeah.
So we did motion, or we did vectors, and we had vector questions.
Yeah.
Similar to that, I think she did the whole syllabus with her, the stuff that we did with her.
Yeah. Let's do that. Yeah. So what you can do, yeah, every week when we have a lesson, you send me the questions, right?
Yeah.
And then you say, sir, look, let's do this question. And I look at the questions here. You've got the questions at home. Then I've got the whiteboard over here. And on the whiteboard, we do them together.
Yeah.
Does that make sense?
Yeah. Like a link.